Hi, I'm Courtney Targus, and I worked with the Shirley Hines Land Trust, which is a land restoration, and their mission statement is to protect habitats and ecosystems of Northwest Indiana through acquiring, restoring, and protecting environmentally significant landscapes for present and future generations, and to inspire and educate people of all ages about the value of land conservation to protect our natural world and enrich our lives. Okay, this is the prism. It's just a small piece of glass, and when you place it in front of the tree, it diffracts the piece of the tree so that the tree will either count or not count. So what you do is you place the prism directly over the plot point, which is the orange flag. And then starting north, you look at every tree and see if it counts. Now if the tree counts, then you use the diameter tape and you measure the circumference of the tree, or diameter. And then you also note the species of the tree. Now, if it is borderline on the prism, you need to measure the distance from the plot point to the tree, and then the diameter of the tree, and then there is a chart that you look at, and it'll give you whether it counts or not. Okay, this is the densiometer. It's just a small wooden box, and then when you open it up, it is a concave mirror that consists of 24 squares. Each square represents 1.04% of the sky. So to take the reading, you do this in all four cardinal directions, starting with north because it's easiest. And then you place it 12 to 18 inches in front of you. Make it level using the little bubble level in the right-hand corner. And then you count either the number of squares occupied by sky or the number of squares occupied by trees. And then you multiply that by 1.04%, and that will give you the percent of canopy cover for this plot point. And then you do that for all four cardinal directions, and then you average them out to get that canopy cover for that plot point. Okay, right now we're going to run the belt transect. What you do is you take a compass and you run due north or south, whichever way you're doing it at that point, until the next plot point. This is only a 50-meter tape, so you're going to do it 2 times to get to the next plot point. So now what you do is every 10 meters, you're going to stop and you're going to look to see if there is a woody species. If there is, then you identify what it is and either classify it as 1 or 2. 1 is for up to 1 meter, and 2 is for more than 1 meter. So at 10 meters, there's this little woody species, so you identify it as an ash, and then you classify it as 1 because it is less than 1 meter. Okay, so now we're going to do the herbaceous layer, and to do that, you, from the plot point, use the compass and due east and west. You take the meter squared quadrant, which is right there, and you go 1 meter out because right next to the plot point is usually trampled. So then you come up here and you identify all the different types of species of plants that are in the meter squared. So there's fern. So then you count all the numbers of fern that there is, and then you give it a class, which is 0 to 5% is A, 5 to 25 is B, 25 to 50 is C, 50 to 75 is D, and 75 to 100 is E. So for this meter squared, I would say that there was about 75% fern. And then you would do that for every species in here.
Hi, I'm Lauren and I work for NRMI. NRMI stands for the Northwest Indiana Restoration Monitoring Inventory. What NRMI does is it goes to restoration sites across the region and collects data of what vegetative life lives there. And this is in hopes of creating a unifying effect throughout all the restoration efforts in the region by providing an open database of all the vegetative life in order so people can track the progress of the restoration. When you go to a new site, you want to pick a homogeneous area of plants to set your plot in. A plot is generally 50 meters by 20 meters, and you use a flag at each of the corners, so you'll divide it into 10 by 10 modules. You put a flag down, and you start from the flag and measure out 50 meters. Once you complete the plot by putting a flag down at each of the corners, then you use the GPS, it's the Garmin system, and you mark a new waypoint at each of the flags. You'll have 18 altogether. This information will later be uploaded for future reference. There are 4 intensive modules in the plot, and you'll put a PVC pipe frame down at the corner with a flag. There will be 8 intensive corners that you'll monitor. We'll have 1 meter squared area, and also a nesting 1/10 of a meter squared, and within it taped markings to show 1/100 of a meter. The smallest will be considered a level 5, and then a level 4. The meter squared is level 3, 10 meters squared is level 2, and the entire module is a level 1. After you record all of this data, you'll go throughout the rest of the module to see what wasn't in your intensive corners, and then when you're completely done, the 6 other residual modules. Most of the plants will already be recorded, but you need to do this just to scan to make sure everything is entered. To record the data, we use the CVS protocol, which stands for the Carolina Vegetation Survey. In this, you'll fill out the data sheet with the team members, site, plot number, and then in the columns you'll have the modules and corners and cover code. Under the corners, you'll put what level each of the individual species was found at. Each species will be recorded by the scientific name, which you'll find in Swink and Wilhelm's Plants of the Chicago region. The plants are given a 6-letter code with the first 3 letters of the genus and the first 3 letters of the species. For example, Solidago canadensis would instead be SOLCAN.
Hi, I'm Candace, and I work for Save the Dunes. What we do is we test parameters of the stream. And what I'm going to do today is measure all the parameters with the sonde. I'm going to measure the flow or velocity of the river with the flow meter, and I'm also going to show you how to take water samples. The point of Save the Dunes is to find the best kind of practices for people such as farmers or just people living in rural areas and urban areas, and we're trying to implement the best kind of practices to reduce water pollution. To measure the parameters of the stream, you need an instrument called the sonde. And what it is, these little probes measure different parameters. This one measures pH and conductivity. This one measures dissolved oxygen and percent saturation of that dissolved oxygen. In order to use the sonde, you stand downstream and hold the probes upstream of you. And you go in the middle of the stream and you put it halfway down the water column so that the probes are getting equal flow of water. And then you look at the numbers here on the screen, and they all have to stabilize. So the last one to stabilize is dissolved oxygen, and that usually takes about 5 minutes. You need to store them. In order to do that, you scroll over using the over arrow to store, and you press enter, and you press it again, and then it'll load back up. In order to review your numbers to record the data, you press the left arrow over to review, and then press enter, and it'll give you a number that says 00. In order to review the last data you collected, which is the one that we want to see, you scroll down once, and then I'll give you your entire data. The thing we are going to do is measure the flow of the stream. In order to do that, you need a data sheet. But if you work for Save the Dunes, you'll learn how to do those calculations later. So, what we're going to do first is string this tape measure across the stream in order to get the total width of the stream. If the stream is greater than 15 feet, you're going to divide the stream into 10 intervals. So if it's less than 15 feet, it's only 5 intervals. And obviously, the stream is less than 15 feet.